Hello, my wonderful scholars and mathematicians. I hope you are having a safe day, a good day. I hope you had a great weekend, and I'm really excited to get to work with you. If you were in class earlier and you were able to do this problem along with us, awesome. If not, I hope that this video helps you understand what you are being asked to do in this application problem. So let's get started by reading it, right? So it says, Marie wants to create a playpen for her bunny to hang out. I'm sure a lot of you have seen Marie's bunny on our Zooms, and so she wants her bunny to get a playpen. On her floor, she clears an area of 6 feet by 3 feet. Then she puts up a gate that is 3 feet high. We have two questions we need to answer here. The first one is, what is the surface area of the floor of the playpen? So surface area is actually just like area, right? It's area, but when we're dealing with volume, remember, because it's something that's 3D, it's one of the sides. So for this, when it says the surface area of the floor, it's asking about what is the total area that is covered by the floor here. And we'll get to that in a minute, right? But I'm just going to write A for area. And then part B is what is the total volume of the playpen. So we're looking for two things here. We're looking for the surface area and we're looking for the total volume. So let's go back in and let's read this story again to see what information we've got. It says Marie wants to create a playpen for her bunny to hang out. Awesome. So Marie's creating this playpen. So on her floor, she clears an area. I see the word area, right? So I'm thinking that that has something to do with this, of 6 feet by 3 feet. So if you remember area, we talked about it a little bit in 5th grade, and I know you do it in 4th grade as well. Area is the length times the width, right? So in this case, if it's 6 feet by 3 feet, then the area is going to be 6 times 3. And you can almost think about it like, let's say this is Marie's floor here, right? I know that's not perfect, but we can go with it. If like this is her if this is her entire room that we're talking about, right? This is the area that she cleared for the bunny playpen. And it's 6 feet, so on this side is 6, FT for feet. And then on this side, it's 3 feet. And because it's a rectangle, I know that if this side is 6 feet, then this side will also be 6 feet. And if this side is 3 feet, then this side will also be 3 feet. But I don't actually need to know that for area because it's just one length, or just this one side here. That was bad, but hello, sweet girl. This, right? This, the length, times this, the width. So 6 times 3 is 18. So the surface area is 18, and because it's area, we need to say square feet, or we can say feet. That's weaker. Squared. This is how we would show area. The area is 18 feet. Again, that means that the amount of space that she cleared on her floor was 6 feet by 3 feet. And then it says, if we go back to the problem, so we've actually solved this first part here that says, what's the surface area? We solved it. It was 6 feet by 3 feet. 6 times 3 is 18 feet. And then it says, well, what is the total volume of the playpen? So what we talked about earlier, and it also says she puts up a gate that is 3 feet high. So now we have a gate as well, and it's 3 feet high. We've talked about that volume equals length times width times height, right? Don't you dare get on this computer right now. Length times width times height. But if you'll notice, area is length times width. So we've actually already done that part. We solved this already and I'm going to change the color. I'm going to go back to that blue that we had used to show area. We had solved this when we solved for area. Length times width is really just area. And the area was 18. So now all we need to do is 18 times the height. And what did it say the height was? It was a gate that was 3 feet high. So we can imagine, right, Marie's cleared this area, and now she's putting up a gate to make sure that her bunny actually stays in the pen that she created, right? So she's gonna put up this little gate here, right? And I know that's not perfect, but if we imagine that it's this whole thing is 3 feet, then we now have 18, or this surface area, times 3, or the height, and 18 times 3, or I actually can't do that off the top of my head, that's fine. I know it's the same as saying 18 3 times. I could think of it even as 3 layers of 18. 18 plus 18 plus 18. 8, 16, 24. Put a 4 down here. Carry the 2. 2, 3, 4. 2, 3, 4, 5. So what's the area? The surface area is going to be 54. But remember, now I'm talking about volume, and when it's volume, it's going to be cubed. So I'm going to say feet cubed, and I show cube by doing a tiny little 3 up at the top. Remember, we talked about exponents way at the beginning of the year. It's an exponent of 3, right? So again, what I did here was I figured out the area, or the bottom layer. I figured out the area of that by timesing the length and the width, the 6 and the 3. I got that it was 18 feet squared. And I then used that to help me find the total volume by saying, well, the length and the width, I already know what they are when I multiply them. They are 18 times the height times that 3 is 54. So what we can learn from this is actually, and I'll do this even in a third color, that if I do volume, yes, this is totally awesome, right? This length times width times height thing is awesome. But if they ever don't give us the length and the width separately, but they say that something has an area of something, then we can actually figure out the volume by doing area times height, right? And I know that's a little messy, but it's area times height, which is actually what we did here as well. Now, if you wanted to check it, you could do 6 times 3 times 3, and you would end up getting this as well. You would end up getting 18 times 3, and you would get 54. So I hope that was helpful. Please, of course, let me know if you have any questions, and I will see you later. Bye, scholars.